In the beginning, our planet consisted of a ball of melted materials with a cooler, solid crust on the outside. As the melted interior churned, the solid crust floating on it broke and cracked into pieces called plates. When these plates collided, the heavier rock was dragged back into the Earth, and the lighter rock stayed on the surface. About 1880 million years ago, the North American plate collided with the southern continental plate, and our plate was pushed down and underneath it. This is called subduction. The red line is where the plates meet. A deep trench formed there, like the Mariana Trench near Japan, the deepest place in the ocean. Now we move on about 20 million years later. It takes a lot of pressure to push seafloor underneath another plate. This folds and crumples up the rocks. The friction from the rocks bending and grinding, plus the heat from the inside the Earth, causes the rocks being pushed under to melt. Melting rocks rose up to form volcanoes south of us. As the two plates pushed together, the volcanoes and all the seafloor sediments were bulldozed onto our continent. This formed mountains as high as the Rockies, just north of where Luck would someday be. What do you suppose all this looked like? This picture shows a view from the south. The sea south of Luck was filled with active volcanoes, and if you look north, you would see mountains that look very much like the Rockies. Now we'll move along to 1850 million years ago. Once the seafloor on our plate was all pushed under, the direction of subduction reversed, and the seafloor on the plate south of us was subducted. The deep trench shown here was just south of where Luck is today. "10 million years later, or 1840 million years ago, the seafloor being pushed under was beneath us, so volcanoes formed all around Luck and across northern Wisconsin. This picture shows what all of this must have looked like. Luck was now on the coast, and the sea would have been to the south. Volcanoes would have been all around, similar to the coastline around Mount St. Helens. The mountains north of us had grown even larger as the two plates continued to push against each other. Now they'd become as big as the Himalayas. "1,500 to 1,200 million years ago, once all the seafloor had been swallowed up, subduction came to an end, and the plates stopped moving. Over time, the mountains and volcanoes eroded away, filling the valleys and low areas with eroded material. "1,109 to 1,084 million years ago. A hot spot formed under Lake Superior area. Magma, or melted rock, built up deep underground and pushed up. This pushed Wisconsin away from the rest of North America, forming a rift or crack in the earth. This rift formed a low valley and was bordered by low mountains pushed up by pressure below. The Rift Valley ran from Kansas through Iowa, up the St. Croix River Valley, under Lake Superior and lower Michigan, and down to Ohio. On this map, we can see that lava oozed up from this rift, filling the valley and covering Luck, Taylor's Falls, and Minneapolis. In some spots, the lava was 2 to 3 miles deep. In the center of the rift, the lava was 14 miles deep in spots. Today we can see the remains of this weathered basalt at St. Croix Falls and Ivers Mountain in Laketown, just northwest of Luck. This picture shows what it all may have looked like. Luck was very near the rift, so it should have been located deep inside the Rift Valley. The area around us would have been similar to much of Iceland, with active lava flows and geysers all piled up on older lava flows. Low hills and mountains lined the Rift Valley. There were still no plants or animals at this time. Another plate ran into North America around 1,040 million years ago. This was a collision that formed the Appalachian Mountains. It also stopped the rifting in Wisconsin and pushed it back together with the rest of North America. The blocks of rock that dropped into the rift were shoved back up. Now we move way ahead to 500 to 260 million years ago. At this time, shallow oceans covered the area, and they came and went. Sometimes Luck was on the shoreline. Other times Luck was well inland, and sometimes it was under the sea. A lot of sandstone, limestone, and shale were formed here, and these rocks still cover most of southern Wisconsin. Life became abundant in the seas around this time, and about 400 million years ago began to spread to the land. This picture shows what it may have looked like. When Luck was on the shore, it would have been a somewhat barren place with a sea to the south. A few land plants may have been visible, and a few insects like scorpions may have roamed about. When Luck was beneath the water, life would have been everywhere. Luck would have been populated with ancient relatives of the octopus, corals, snails, clams, water plants, and animals that looked like flowers, as well as trilobites, which were animals that looked very much like buds. The seas finally retreated. Now we move way ahead to about 3 million years ago to the present time. The climate of the Earth changed again, and we entered the Ice Ages. Glaciers covered Luck and northern Wisconsin 4 times. The ice moved over us in sections called lobes, and their routes were determined by the hardness and height of the rock beneath the ice. What you see around Luck today is mostly what was created by the glaciers and the water from these glaciers melting away. This map shows that most of Wisconsin was covered by ice, but not the southwest corner. This corner is called the driftless area. The landscape there was carved from water only and looks much different than our area. Lakes that formed as the ice melted and retreated, and the river valleys carved out by the meltwaters were very important in creating our landscape. The ice would melt and the water would need to find a way to drain away. Often the ice would dam up the water, and then, as the ice melted away, the water would suddenly be released when the dam broke. Vast amounts of very fast-moving water would rush out, carrying a large amount of sand and rocks carried within the glaciers. This cut deep into the land, forming river valleys like those of the St. Croix and Mississippi rivers. The melting of the superior ice lobe sent a lot of water down what is now the Brule River Valley and into the St. Croix Valley. The huge flow of water from Glacial Lake Duluth cut the gorge at Taylor's Falls, creating the features that we now see at Interstate Park. This picture shows what it all may have looked like. After the glaciers were gone and the water had drained away, things looked much like they do now. While the glaciers were here, things were very, very different. Luck was buried under a mile of ice, and it would have looked very much like Antarctica. What did the glaciers do to our landscape? Glaciers are like giant bulldozers. They scrape off the soil and grind up the rocks underneath, and then carry these things along as they move. When they melt, all the rock and dirt that they pick up gets left behind. Some of it piles up, some is washed away by the meltwater. These are some of the landforms made by the glaciers. We have to thank the glaciers for our rich farmland. The glaciers and the meltwater made the valleys and hills and pretty much everything you see. Here we can see some of the more specific landforms that glaciers made. Many of these are found all around us, but most have been eroded over time and are hard to pick out. Some, like the more numerous small ponds and lakes around us, are very easy to find. Some of the places created by glaciers and their meltwaters were so remarkable that they were turned into parks. The formations at Interstate Park were created by fast-moving meltwater carving into the rocks created by the lava flows long ago. The new park near Luck, Straight Lake Park, was created by rivers running beneath glacial ice. Channel tunnels and eskers are both the result of streams running beneath the glaciers. Slow-moving water is not able to carry away all the material in the ice, and the heavier materials sink to the bottom and pile up. This forms an esker, a snake-like ridge, after the ice is all gone. Fast water and extreme amounts of water carry away all the sand, gravel, and rocks in the ice and use them to cut away the rocks at the bottom as the water flows. This cuts a riverbed into the bedrock, forming a channel, called a channel tunnel, because it's a channel cut inside an ice tunnel. Straight Lake and Straight River were formed when there was a drop in the water temperature in the tunnel channel, which again froze and filled the channel. Another stream formed beneath the ice inside that channel. This time, slower water deposits and materials built up an esker in the middle of the channel. Straight Lake and Straight River is one of the best examples of channel tunnels in Wisconsin. The following pictures show Straight Lake and Straight River from the air. These were taken in the evening during low light to better show the channel tunnel valley.